3 keys, held by 3 people, open one vault in a basement outside Paris. Inside, under 3 nested glass jars, sits a metal cylinder the size of a golf ball. That cylinder was the kilogram, and it was losing weight. For 130 years, that was impossible. Not difficult, impossible. If a cylinder defines the kilogram, then whatever it weighs today is 1 kilogram, exactly. So how do you weigh the one object that decides what weighing means? Start with something that sounds wrong. No scale on Earth measures mass. They all compare. A kitchen scale, a lab balance, a weighbridge, each one puts the unknown against something already trusted. That weight was set against a better one, in a better room, with better instruments. Follow the chain far enough and, until 7 years ago, it ended in one place. In 1889, the first General Conference on Weights and Measures sanctioned a single cylinder as the world's mass. 90% platinum, 10% iridium, an alloy that resists corrosion and polishes hard. 39 millimeters tall, 39 across, because that shape carries the least surface per volume. The shape was a defense. A surface is the only part an object shows the world, so every measured mass on the planet leaned on one lump of metal in a safe. And the surface they protected so carefully is where it went wrong. You would think they weighed it regularly to check. Nobody could. There was nothing to weigh it against except copies of itself. 6 sit in the same safe. Metrologists call them the witnesses. Between 1988 and 1992, the third periodic verification compared them, pair by pair. They had drifted about 50 micrograms apart across a century, roughly a fly's wing. Nobody could say which way, the copies gaining, the original shedding, or both at once. Because the original was exactly 1 kilogram by definition, the arithmetic ran backwards. If it shed 50 micrograms, the kilogram shrank, and everything else in the universe grew, in the numbers. Stefan Schlaminger of NIST says it plainly. Drop that cylinder, and the mass of the world changes. Contamination was the best guess, so every few decades someone wiped it with alcohol and ether, then steamed it. Afterwards, its mass crept upward again for days, and nobody has fully explained that. The metal was never really the problem. The definition was. Down the corridor from that safe lies another platinum-iridium object that nobody uses anymore, the meter. A bar with 2 fine marks on it, the world standard for length until 1960. Length got out in 2 steps. First, it became a count of wavelengths from a krypton lamp. Then, in 1983, the speed of light was fixed by agreement at 299,792,458 meters per second. After that, a meter was just how far light travels in about a 300 millionth of a second. Nobody needed the bar. It sits in the same building, retired, doing a job that no longer exists. Mass was the last base unit still tied to an object, and mass is the hard one. You can count wavelengths of light. Grams cannot be counted, only compared against another lump of matter. What you need is a balance whose second pan holds something that is not a thing. In 1975, at Britain's National Physical Laboratory, Brian Kibble worked out how. The machine carries his name. It hangs a kilogram on one side. On the other, current runs through a coil inside a strong magnet. Current in a field makes a force, so you raise it until that force exactly holds the weight. So far, it is an ordinary balance with an electromagnet for a second pan. It has a fatal flaw. The force depends on the magnet's strength and the coil's exact wire length. Neither can be measured well enough. Kibble's answer was to run the machine twice in 2 different modes. Take the mass off, cut the current, and move that same coil through that same magnet at a measured speed. A moving wire generates a voltage, and that voltage contains the 2 quantities you could not measure. Put the two modes together, and those unknowns cancel, leaving mass times gravity times speed equals current times voltage. Mechanical power on one side, electrical power on the other. Voltage and current can be pinned to two quantum effects, Josephson and quantum Hall, both set by Planck's constant. So the machine weighs a kilogram against a number from the quantum world. Underground at NIST in Maryland, they pinned that constant to 13 parts per billion. That is the Delhi to Mumbai highway, measured wrong by about 2 centimeters. And then, having measured it better than anyone in history, they stopped measuring it. On November 16, 2018, at Versailles, delegates from 60 countries voted unanimously. Planck's constant is now exactly 6.62607015 times 10 to the minus 34. By agreement, forever. From that number, the cesium second and the speed of light, the kilogram now follows. The cylinder is still in the safe, still under its jars, behind the same 3 keys. It is just not the kilogram. It has a mass now, with an uncertainty. It was not destroyed. It was demoted. The part I find hard to sit with is the cloth. Nobody was careless. That was just the ceiling for objects. You cannot weigh the object that defines weighing. So the definition left the object. It went to a number, and a number cannot be dropped or cleaned. Every scale you trust now traces back to that number, chosen to match the old cylinder, then frozen. 3 keys still open that vault. Nothing inside it is the kilogram.